So we've been pretty busy over the past year or so.
Yeah.
Working at Walmart.
I know, it's been fun. We used to be like really in the weeds on all this technology and working on platform teams and then building products. And now we seem to be kind of abstracting to different things, getting more involved in the product.
And as we do that, as we start building, we built a mobile website over the past couple of years. Now we're working on the desktop website. We sort of reflect on how the web's gotten pretty complicated. And we see this, too, as we hire sort of more junior members on the team and reflect on what's changed in the web stack through the years. And it's really daunting when you take a step back and consider what the web was and what it is now, because it used to be this really simple platform to get ramped up on, and it just seems like it's getting more and more complicated as time goes by. And as you look at this from the stack perspective, you sort of see that it's really, really complicated.
That's right. I mean, it started off as just this document platform, and then we add styling to the mix, and then we go and add behavior to the mix, and then we start getting into the world of cross-browser and apps, and all of these things just kind of keep adding and adding to the stack that we have to deal with, all day long, up until like the rich app frameworks that we're learning about, and then being able to get across, through responsive design and other means across all of the different devices that are out there.
And that's just on the front end. When you consider the server-side stuff, each of the server-side stacks that you deal with has its own universe of complexity that's associated with it. And you got to deal with that. I don't know how many of you find yourselves in debates about what framework to use for this or for that. We're doing a lot with Node, and the team decided there that they had to build their own framework. What a surprise. And the complexity is just enormous on this side, too. And this is assuming that you've even figured out what you want to build. We talked last year about the decision between web versus apps and the complexity that comes with that. And you start to really realize just how complicated this is and how many decisions there are to make.
Yeah, I mean, a lot of the great things about the web is that you do have this choice, and you can pick A and they can pick B, but we also know that too much choice does not lead to happiness a lot. Ben and I have worked on different projects where we would totally argue about, prototype versus Dojo back in the day. The back end of Bespin was Python for a while, it was Java for a while. We spent a lot of time on those topics.
It can be painful. And, in computing, we have a tool to use when the complexity starts to overwhelm us. Abstraction, indirection. We sort of wrap the complexity and build towers on top of it. And we see this in a lot of different areas that have been really successful for us, like the whole notion of assembly being wrapped with C. Functions, the humble function can really be sort of a magical piece of abstraction. And so we shove this abstraction further and further down. Networking is another great example. I think Gui Tool Kits are, for me, one of the most compelling examples of the power of abstraction, where if you reflect for a minute about how complex it is to draw pixels on the screen, user interfaces that respond to user input, or animations. I love the core animation framework and all the other core frameworks that Apple's created. You start to sort of realize how powerful abstraction can be. And then you reflect on ORM, for example.
Right. We've also seen lots of poor or bad abstractions. Right. I actually worked on this thing JDO in the Java world and the standards group, where there was a theoretical, magical, mountain that we wanted to climb, which was you should be able to access any type of data store through one really nice API, and it should just work seamlessly. And it was a disaster. And this little open source framework, Hibernate, came along, which just said, you know what? I'm going to say we're using SQL as the data store, and I'm going to let you get into that world. And so trying to reach for that really high level of abstraction was actually a disaster. It took you too far away from the meadow, and then something that came in at a different level actually helped out. And we see that in other ways too, like in the notion of like text files seems so primitive, right? It's just like, really, that's where we're at? We have to type text in to Assistant? Surely there's a better way.
And 4GL is another example where the Gartners of yesterday predicted that 4GLs would come along and abstract away all the complexity of creating applications, but that never really happened. And I think Joel Spolsky is one of my favorite authors on the subject of explaining why some abstractions work, why others don't, and the challenges associated with creating these abstractions that try and drive productivity. It can be challenging. But when abstractions fail to fully hide the complexity, it's not to say that they're not useful. I think GWT is a great example of an abstraction that gives you some productivity, but you'd be insane to try and use GWT without fully understanding what's underneath. And I think we see this in the CSS space too.
Absolutely. It's been interesting to kind of see that as people get into these tools and really understand a platform, and you become a master, you become an expert, you want to build tools to make your life easier. And so, SAS is a great example of something that comes along, things that you commonly want to do. you want to be able to fix that. You want to set variables so you're not doing a search replace and you know, keep things simple and the like. But what was interesting is seeing kind of what came out of that world. What were we dealing with in that world? With CSS, it seems like it's a simple thing, but it's actually not that easy. It seems like you can just copy and paste, but in reality, you need to understand these different box models, and there's a lot to it. When SAS first came out, they had kind of their own DSL, right, which is their own way of looking at things that would generate into CSS. But then we start to see other solutions, like at Walmart, we actually use Stylus, because we like how you can just take CSS and then kind of add on the things that you want without having to learn this new way of doing things. And so again, choosing that right level of abstraction really helps you as you're making your different choices, you're building software.
So I think Ken Beck explains a little bit in this tweet about what happens when you pursue abstractions that aren't complete. You have to fully understand what you're abstracting in order to really be productive with it. And when people don't do that, that's when you see examples like this, where you're trying to get work done, but you really don't understand what's happening, and you make really poor decisions, and it leads to the culture of Stack Overflow so often, when you're just out there, you don't really understand what you're doing, you're using these partial abstractions that don't really hide the complexity, and you're just trying to make it work. And so for the web, it feels like we don't really have a lot of great abstractions that shield us from the complexity that we've been reflecting on earlier that's out there due to all the evolution we've seen over the past few years. We have a lot of libraries and frameworks that are out there, but sort of this comprehensive abstraction that makes life simple for us seems elusive. And as we look at other abstractions in our industry that manage to shield us from some of this complexity, you start to see some patterns. Like with C, you see deep integration between people who are working on chips and processors, understanding how C compilers will create assembly that's going to be optimized for their instruction sets and can tweak that. You see that with PostScript, where you have this entire ecosystem of tools and editing tools and printers and even some display libraries, in the case of NextStep and others, end-to-end integration. And you see this with iOS and the Mac to a degree, where you have deep integration, and so it enables you to create these powerful abstractions that are really, really impressive.
There's something interesting about the web is that, because of its heritage, what is it? Is it this document platform, or is it an application platform? And I think we're kind of struggling through the evolution a little bit here to kind of work out where were we really going with this. And the context is really important. For us at Walmart, we're kind of in between. When we look at the e-commerce site, you look at like the product pages, that's very much documents, content, Google has to come see it, we need to get good SEO. But going through cart and checkout, that's kind of an app-like flow. And so often on the web, you're kind of in this in-between world.
Yeah, and when you ponder, how do you get that deep end-to-end alignment in the web when the web is as far from a dictatorship as you can find? It's just sort of this democracy. And when you have a democracy that's polarized, that's almost the worst possible situation. And we discovered that when we worked on, Dion mentioned Bespin earlier, we built this web-based code editor back when Canvas was new, and we were really excited to have app-style primitives in the web platform, an arbitrary rendering service that we could use to create this editor. And we were surprised at how many people attacked us for that, feeling like we'd broken the culture of the web and creating this primitive that we could build on. And so as we, as web developers, try to create abstractions that solve problems that are described in this slide, that sort of bedevils us. This fact that because it's a democracy, it's hard to get alignment to create what's necessary to get these great abstractions that shield us from the complexity.
Right. Exactly. We don't have the right primitives, right? I don't know if you've been through these kind of things where you see this amazing component on one library and this other one in another library. You just want them to work together, but you can't do that in a nice way.
And so that's one of the reasons why having Google fork WebKit to create Blink is really exciting to us, because it's a step towards adjusting the stack so that we can start to see these high-quality abstractions emerge that really make us more productive. And in fact, if you go and you look at the FAQ for Blink on some of their goals, they call out the complexity that we've been discussing and acknowledge what they're doing with Blink as an attempt at that. And we further see what productivity improvements await with a strategy like this with web components.
Yeah, so at Google I/O they announced Polymer, which is a way to kind of drive this into some of the older browsers too, but we're fundamentally seeing that a lot of the folks that worked on these frameworks, like the Alex Russells of this world, they couldn't get far enough building on that platform. And so what we're seeing is that we're actually kind of going back into the platform itself and adding in the primitives that we need. We need the primitives of components. We need to be able to scope things. We need to have encapsulation. And web components is something that I'm really excited about, because it's hopefully going to kind of give us these primitives that we've been craving for a long time that allow us to scale our applications.
And you have to have deep integration all the way down to be able to build these primitives, which is really interesting. But because largely these primitives escape us now, and if you look at what's happening with Blink, it's exciting, but there are other browsers in the ecosystem that we need to support in the meantime, we're stuck with this complexity. And complexity is pretty scary for a lot of reasons. Let's just imagine a graph with complexity as the x-axis and predictability as the y-axis, and you see an inverse relationship. The more complex systems become, the less predictable they are, and that spans beyond technology. Relationships, for example, the more complicated the relationship, the harder it is to predict what's going to happen at the end of it. The financial system, if you go back and look at what happened in the financial fall, the financial crunch like 5 years ago, it had to do with the complexity of the financial instruments that led to situations where no one could predict the outcome, except for very few people who'd taken the time to sort of solve the equation. And in IT, we have this issue too. The more complicated the systems we're trying to build, the more complicated they become, the less predictable the outcome, and the more failures emerge. Complexity is really pretty scary.
And it's funny, you talk about the stock example. Like, I think it's very easy to think of, we're in this modern society where there is this complexity, and like, man, I wish I could hark back to the other era where things seem so simple. Like now we have to deal with this burden of complexity, but back in the day, life was so much simpler, right?
Yeah, we were actually looking a little bit in history as we prepared for the talk, and we were reminded of the mother of all demos. How many people are familiar with the mother of all demos? This happened like 40 years ago. This is kind of spectacular. Out of nowhere, this guy, Doug Engelbart, did a demo here in San Francisco of a bunch of new technologies where he introduced to the world the notion of the mouse, the word processor, hypermedia, hypertext, video conferencing, telecom, like all these concepts.
Collaborative text editors?
Collaborative text editors, 1968. Yeah, crazy. And it just sort of exploded on the scene. And we're still influenced heavily by what his team produced. And if you go back and you look at why he did that, this is from a talk he gave, I think, 15 years or so later. He said that, complexity was my goal. I wanted to solve complexity for humanity. And he talked about how his goal in doing this was, first, he sat back and he said, I want to give back to the society. I want to serve people. And I think helping people solve for complexity is how I can serve humanity, which is horribly ironic because, if anything, I think he made complexity worse by foisting all these new technologies on us. And it sort of illustrates the danger and the difficulties associated with complexity. It's non-trivial to get rid of it. And for us, I think one of the big problems with complexity in the context of building web applications, the more complexity is involved, the more decisions have to be made. And there's something called Parkinson's law, which we also refer to as bike shedding, this notion that for some reason, as technologists, we seem to be irrevocably drawn towards the temptation of debating really trivial things. And bike shedding refers to the fact that we seem to spend so much of our time arguing about the color of the bike shed instead of talking about the bikes inside of the shed. And so for us, as we've been building software over the past few years, we started to really ask ourselves, how can we develop a culture that focuses on the decisions that matter, that focuses on the users and really the substantial decisions and less on this complexity? And as we've thought a lot about this, we've realized how super important it is to develop this culture of focusing on what the user wants to get out of it. And in software, a lot of times we're tempted to sort of delegate all this to the UXers, right? Or just say, the UXers or the PMs are going to focus on it, and we're going to dive deep on technology. But to get software right, it requires a full commitment from everyone on the team. And you see things like the scenario described by Donald Norman in his fantastic book, The Design of Everyday Things, where he talks about 3 Mile Island. Now, 3 Mile Island has had an enormous impact on society. For years now, it has made us feel, or a large segment of society feel, like nuclear power is just not worth the risks. And if you go back and you look at it, it turns out that 3 Mile Island, that scare, wasn't about anything to do with nuclear power. It was about usability. The control rooms had been designed in such a horribly unusable way, and if you read the book, it's comical how bad it was, that it led to operator mistakes that led to the scare, which in turn influenced decades and decades of thinking. And it's only now, I throw the slide up because this is a documentary that has come out which documents a lot of people's decades-long efforts to sort of back out of the thought processes that they've had about nuclear power that are all due to a usability problem in software. The good news is, as we reflect on how we can focus on users, there's a lot of great tools out there. From the classics, About Face by Coop is one of my favorites. Lean UX, I think, is your favorite these days, that sort of talks about how we can build this culture of focusing on the user.
Right. And I think what's important about Lean UX is it kind of feels good to me because it kind of acknowledges that you are going to fail, right? And that you don't know things. There's not this holy grail. There's not this silver bullet that's going to come along and is going to kind of just show you the way. The answer is X or the answer is Y. Because, again, context is just so important to whatever it is that you're actually building. And so more and more as we get into the weeds, we learn about the different nuance that's in there. It kind of talks about, going back to Ken Beck's, understanding the abstractions, actually being mindful of these things and knowing where you stand right now on a particular project. What are the different trade-offs and what are you doing? Maybe now it's time to move because some of the context changed. It's okay to have a nuanced position rather than just kind of going whole hog on one side of things. And so that kind of skill is a skill of agility. Yet in our world, we often think of agile with a capital A, and it's all about agile means these different things. Turn it up to 11. Do you do a stand-up? Are you going through and do you have 100% code coverage? And it's all about the rituals, and it's not about being mindful of actually why you're doing those rituals and what's actually happening with your project. And we see this time and time again as, you see a small group that's doing great stuff, and a big boss comes in and is like, oh, okay, we need to do everything agile in the company, and we just throw everyone the book, and everyone becomes Scrum Masters, and it's all about learning the recipes rather than actually getting the understanding. You look at kind of definitions of agile, they don't mention the dogma. It's all just about being able to adjust. And we think that being able to mindfully make those adjustments has been critically important to us as we kind of go through and build out the products. And the web is amazing for doing that because it gives us a way to continuously deploy and run as many experiments as possible, giving us a direct connection to our end user instead of abstracting it through an app store experience.
That's actually something that really, as you were saying, and I just want to emphasize that, sets the web apart because of all the platforms, the web has powerful, unique advantages in tightening that loop because we have that direct connection with the user. The other platforms, especially the competitive platforms that have emerged over the past couple of years, all have these intermediary gates that in some cases try to control whether or not you can ship the application, and at best just slow you down and prevent you from deploying 5 or 10 times a day so that you can continuously adjust, which is the key to creating these sort of great user-centric experiences and force you to deliver on a much slower cadence. So it's super important to have these loops, but one of the things that we found is that, in software you don't physically see a structure, and so you sort of lose track of how complicated refactoring and how expensive refactoring can be, and you can save an enormous amount of time and contribute meaningfully to the success of your project if you understand up front sort of basic facts that you can incorporate in your process that span any domain that contribute to success. And Jeff Raskin calls these universal psychological facts. And understanding these up front can have an enormous impact on the quality of the software that you produce. There are a few of these that we've found are enormously important. And we wanted to cover, I think, a couple of these. One, let's lead into with loss aversion. So loss aversion is this funny concept that as humans, we're more afraid of losing something than gaining something. And there's a ton of science behind this, and there's a lot of fun anecdotes around this. Like, how often in the Valley do you have a friend who's made it super rich with some speculative startup? And so often, the pain that you feel at having missed out is so much more intense than the joy that you feel when you do actually get your meal ticket. And what's also interesting is that this applies to time as well as money. And there are increasing studies out there that relate that losing time creates these really deep feelings of aggravation that are stronger in people than the feelings they get when they save time. And so that leads to this fundamental insight that we need to create applications that go way out of their way to avoid losing data. And at first I think a lot of us feel like, well, yeah, we don't do anything to lose data. Who would? That's stupid. But on the web, we still have this ingrained culture of sessions. and forcing users to start over when sessions expire. And so one of the core concepts that we found is so super important is to architect software in a way that works around that. And if you're not in a position to re-architect your server-side stack, there's client-side stuff you can do that mitigates this pain a bit.
Yeah, so on the mobile website, everything we do, we've abstracted out local storage from getting the remote data to give you access to the data as fast as possible. You see this a lot in things like Meteor.js, where like change the client, update the data asynchronously, make sure that you're always hanging on to that, and also it really helps with responsiveness too, right?
Absolutely. Like the spinning beach ball effect, this actually has a big impact on users. And this is one that we continuously hammer with our teams. People are enormously sensitive to latency. And if you want to create an experience where people, like the iOS sort of touch experience, where people are just sort of magically engaged with that experience, it's super important to keep that latency as low as possible. And if you can't get a tenth of a second is sort of like the limit before people start to realize that the system is different than them. And so it's super important to keep the UI responsive. And there are a number of technologies on the web that facilitate this. There's the first set of obvious ones. You push as much asynchronously as possible. But local storage and app cache help here too, because you mentioned the mobile website. When you have as much stashed locally as possible as you continually surf the site, and you get instantaneous experiences because you can get them from that local experience. And WebSockets makes it super easy for you to have faster transfer of data, and avoid the initial setup latency every time you want to transfer data. And finally, with the GPU, we can get faster and faster effects to sort of bring the overall time in the UI down. When you follow these principles, you can engage your users in what some people call this flow state. And it's fascinating to study the science here, too, of how happy people become when they have this direct connection with the software system. And it makes us sort of tie it all back to what Doug Engelbart was talking about earlier, and it makes us feel like we can take a page from him and focus on leveraging the technologies we're learning about today. And instead of focusing on opportunities to bike shed and debate, focus on how we can use these technologies to truly serve our users and create amazing experiences that make them much happier. Thank you very much.